So 5, 6 is the half angle identities or formulas. So these two can be derived pretty simply. We went from the sum formulas to the double formulas. I can use a double formula to get to the half angle formulas. Okay, so I'll derive the first one. The other one, I'll just tell you what they are. You'll see how easy they couldn't be derived if you wanted to do that on your own. All right, so using the cosine of 2 theta to derive the half angle formula for cosine. Now I'm going to use cosine of 2 theta is equal to 1 minus 2 times the sine squared of theta. I'm sorry, this is not deriving, this is the one deriving for cosine, for sine that is, so scratch that for sine. All right, so I want to solve this for sine of theta, right? So what I'm going to do is just make substitutions, rearrange the equation around. So I'm going to have 2 times the sine of theta is equal to, this went to the left, this is going to go to the right. So we have 1 minus the cosine of 2 theta. Divide everything by 2. Take the square root of both sides. The plus and the minus on the right. So this solves for the sine of theta is equal to plus or minus the square root of 1 minus cosine 2 theta. Let's do this. Let alpha equal to 2 theta. 2 times an angle is still an angle, right? So if alpha is 2 theta, this gives me 1 minus cosine of alpha divided by 2. And then I can replace what theta is. Then theta is alpha divided by 2, right? So there's our formula. The sine of alpha divided by 2, we just changed our letters from thetas to alphas now. Still a angle, right? Is either the plus or the minus, not both. So we're going to have to choose one. And plus or minus depends on where alpha over 2 lies. So you have to choose one. All right, cosine of alpha over 2. You can do the same technique, except now you use the other formula for cosine of 2 theta. We use 2 cosine squared theta minus 1 and solve for cosine of theta. It comes out the same scenario. I'm rearranging the equation. And you still would see that this would come out to be a plus or a minus as well of a square root of 1 plus the cosine of alpha over 2. So extremely similar formula, right? It's just Sine, the numerator is 1 minus cosine. Cosine is 1 plus cosine. And again, plus or minus depends on where theta alpha over 2 lies. Tangent. Alpha over 2, again, a plus or a minus of, if I would take this whole expression right here for sine, this one for cosine, and simplify it as far as possible, you'll see that this is just going to be 1 minus the cosine of alpha over 1 plus the cosine of alpha under that radical. All right, so these are really easy to remember too. Just remember that you're going to have to always find the cosine of the angle there. Okay. Sometimes it's given to you, it's told to you in the problem, sometimes it's not. If it's not, you have to use Pythagorean identities or Pythagorean theorem to figure out your x over your r. Right? Then the next thing is taking the plus or minus. That's going to depend on what quadrant you're located in. So let's do let's find the cosine, the exact value. Let's say the cosine of 15 degrees. So 15 degrees isn't one of our special angles, but it is half of one of those special angles, right? So this is, say, 30 divided by 15 is half, right? I'm sorry, it is 2. 30 divided by 1/2 of 30 is 15, I should be saying, right? So the cosine of 15 degrees is equal to cosine of 30 degrees divided by 2, half of 30. So here's our alpha right there. So the formula is going to be the plus or the minus of the cosine of 30 degrees, 1 minus 1 plus the cosine of 30 degrees all over 2. But which one do we choose, the plus or the minus? Where's 15 degrees? Quadrant 1, so everything's positive in quadrant 1, so throw out the negative and evaluate. Cosine of 30 degrees, square root of 3 over 2. Right here, you can stop. For me, this is perfectly acceptable. I don't need you to simplify under the radical as much as you possibly can. On MATLAB, we'll want you to do that. So we've got a complex fraction, and let's see how far we can simplify it underneath the radical. Common denominator of all these fractions, a 1 here, a 2 here, a denominator of 1 here is going to be all a common denominator of a 2. So we get 1 times 2 is 2. These 2's cancel, so you get a square root of 3 in the top and a 4 in the bottom. The bottom is a perfect square, so you take the square root of that. So we got top square root of 2 plus the square root of 3 all over a 2. That's the exact value. Now you can double check it in the calculator. You're going to see some decimal. If you can enter all this in the calculator without making any too many errors, too many errors, and having a parentheses here and there, you can verify you got the right answer. All right, let's say given the sine of theta is a negative square root of 5 over 3. And theta is in between 3 pi over 2 and 2 pi. Find the cosine of theta over 2. Sine of theta over 2, I don't know why I said cosine first. And tangent of theta over 2. So cosine, sine, and tangent of all theta over 2. All right, first thing we want to do is, where is theta over 2? Well, if I divide everything by 2 here, taking half of theta, right? That's going to tell me we're in between 3 pi over 4 and pi. So 3 pi over 4 and pi, between those two, that is quadrant 2. So we can already determine what signs we'll choose for cosine, sine, and tangent, right? All students take calculus. Everything in quadrant 2, the only thing positive is sine and is reciprocal cosecant. So sine will be positive. All these will be negative. All right, so I need to find the cosine of theta in order to put into the formula. Cosine is x over r. Right? So sine is our y over r. So we're looking for x. So x squared plus our y, negative square root of 5 all squared is equal to 3 squared. That's x squared plus 5 is equal to 9. X squared is equal to 4. X is plus or minus 2. Which one is it? We're talking about theta here, right? Not theta over 2. So theta is in quadrant 3. X is negative in quadrant 3. So theta over 2 here, theta there. So now cosine is going to be negative 2 over r, which was a 3. I'm sorry, theta was not in quadrant 3, right? 3 pi over 2 to 2 pi, that's quadrant 4. My mistake. So theta is over here in quadrant 4. So quadrant 4, x is positive, right? So positive 2/3. See where a tiny little sign error can mess up everything, right? All right, so let's do the sine of theta over 2. So sine of theta over 2, we're going to take the positive square root, right there. 1 minus. It's the right formula. 1 minus the cosine, 2/3, all over the 2. Again, I'm fine you leaving it like that. I don't care. We can just simplify a little further though. Multiply everything by 3. There's a complex fraction. So that's the square root of 3 minus 2 on the top. It makes 1. 2 times 3 is 6 in the bottom. That's 1 over the square root of 6, and rationalize square root of 6 over 6. Cosine of theta over 2. This one we said theta over 2 again is in quadrant 2. So cosine of that is negative there. Of the square root of 1 plus the cosine of theta, 2/3, over 2. Clean this up some. Same thing, multiply everything by 3. So we got now the negative of the radical. 3 plus 2 is 5. 6 in the bottom. And that rationalizes to negative square root of 5 over the square root of 6 rationalized negative square root of 30 all over the 6. Don't cancel the 30 and the 6, right? The 6 is on the outside, the radical. Can't cancel with things on the inside. And lastly, tangent. Tangent in quadrant 2 again is going to be negative. We've got 1 plus the cosine, 1 minus the cosine. Top. So 1 minus the 2/3 and 1 plus the cosine on the bottom. So 1 plus the 2/3. Again, clear out the complex fraction. You can leave this on my test, I don't mind. You indicated you use the right formula. You've got the correct value of cosine. You selected the correct sign, S-I-G-N, for the radical. This is just elementary arithmetic now. That's 3 minus 2 on the top makes 1. That's 3 plus 2 on the bottom makes 5. So we have the square root of the 1 on the top. It's 1, square root of 5 on the bottom, rationalize top and bottom. Square roots of 5s. So that's a negative square root of 5 all over the 5. All right, so that's your half angle formulas. Pretty simple, straightforward again. It's just using formulas. If you know one, you probably know the other two easily can be derived. If you get them all together, you can derive them from the cosine of twice an angle formula. Any questions?